Welcome everybody to our webinar today. I can see that we've got a few people in the waiting room that are trying to still get in. So we're going to give it about one more minute or so, and then we will start our broadcast. If you could just be patient with us, we'll get started here shortly. Thank you. Welcome everybody to today's webinar. My name is Jill Browning, and I'll be the moderator for today's webinar on the advantages of ultrafiltration as a mobile water solution and how you can benefit. Before we get into our presentation today, I do have just a couple quick housekeeping slides to go over. First of all, hopefully you should be able to hear me speak at the moment, but I do want to just briefly mention that should you have any audio difficulties throughout the presentation today, there are two different ways to connect to the audio. You can connect through your computer or call in through a phone line. So feel free to switch back and forth between those two options should you have any difficulties today. And also, due to the large number of attendees on today's presentation, we have gone ahead and muted everybody's lines, but no worries, you can interact with our speakers still. And in terms of interacting with our presenters today, you can ask your questions through the questions panel at any time throughout the webinar today. So please feel free to go ahead, type up any questions that may come to mind, and we will try to get through as many of those questions at the end of the presentation as time allows. Additionally, we have gone ahead and made available our collection of on-demand webinars that we've conducted over the last few years. You can access more than 50 on-demand webinars over at www.veoliawatertech.com. So please feel free to go over to our website and browse through the variety of different topics that we have listed there to see if any of those may be of interest to you. One other quick housekeeping note that I have here is a PDF participation certificate will be made available to you at the conclusion of the webinar. If that is something of interest to you, please be on the lookout in your email, and you should receive that within about 24 hours or so. Also, at the end of today's presentation, you will receive a quick survey requesting feedback. It should take no more than about a minute or so of your time or less. And for those of you who do complete that survey, you will be entered into a drawing for a chance to win a $25 Amazon gift card. So if you would be so kind as to fill that out for us, we do greatly appreciate your feedback. Now, before we hop into the main part of our presentation today, if you are not familiar with Veolia Water Technologies, we are a leading water and wastewater technology provider, and we offer our clients a variety of technologies, services, and project options. And we also support our clients through a variety of different markets, just a few of which you can see on the screen here. Okay, so now I'd like to introduce our speakers for today's presentation. Mark Dyson is Vice President of Veolia Water Technologies, overseeing its global mobile water services fleet. He has more than 25 years experience in the mobile water treatment sector. During his career, Mark has both lived and worked within the UK, Germany, US, and Kenya, where he has managed the development of the water business for a number of major water treatment organizations. Mark holds a Bachelor's of Science in Engineering and Management from Brunel University and an MBA from the Open University. Additionally, our second panelist today is Tim Clark. Tim is the Vice President of Technical and Execution for Veolia Water Technologies North America. He is a chemical engineer with over 30 years of water treatment experience in chemical treatment, process automation, membrane technologies, and implementation of operational improvements. He has been with Veolia for over 15 years and has a bachelor's in chemical engineering from the University of Tennessee. And now with that, I would like to turn it over to Mark to start our presentation.
Thank you, Jill. Well, good afternoon, good morning to everybody. Thank you all for attending the webinar. So what I'm going to do first of all is just briefly go very quickly through the agenda that we've got planned for you. We've got about 30 slides overall, and we've got some video content. So hopefully the agenda will help you learn more about this technology and what can be available from our mobile water service offering. So first of all, why industrial ultrafiltration for industrial water? Then we look at the UF mobile solutions that we offer. We've actually got a hands-on walkthrough video, so hopefully that'll be quite interesting. And then thirdly, Tim will manage the technical part of the membrane technology and how things function. And there's a second video within that presentation. And then we'd like to put some reality into the presentation really and talk through a few case studies, where we've actually used this technology over the last 24 months. So we've got some customer references. And then what we would deliver to you, should you wish to come to us for this type of service in the future, what's our normal standard approach and how flexible we can be. And then when is it an advantage to rent or buy? We as an organization want to give our customers a choice. They can either buy from us, or from mobile water services perspective, you can rent the assets from us for different time periods. So in addition to the agenda, we've actually got 3 polling questions throughout the presentation. They're quite easy, I hope, to answer, and we'd very much appreciate if you could participate. Keeps a little bit interactive as well, so hopefully you don't lose track, and you can help us with the polling questions.
Great, thanks, Mark. So to kick off our first poll here, and you should see a box that'll pop up here on your screen here, but do you currently use UF technology within your plant? So with that, I will launch it, and you should see a box popping up. And we will give this just a couple more seconds here to see quite a bit of answers already coming in. We're about 62% up, 60% yes, and 36% no. So with that, looks like we've got the majority of people have voted by now, so we'll go ahead and close this poll and share out the results here. So with that, it looks like we've got about 59%, so a little bit over half are currently using some type of UF technology within that. So with that, I will turn it back to Mark here to talk a little bit more through the presentation.
So the first thing is, why ultrafiltration for industrial water? If you look at the overall market, UF is a growing technology that's now being used more and more commonly in industry pretty much over the last 20 years. And if you look at the treatment applications where it's typically used, quite widely used, it's used for the treatment of groundwaters, wells, aquifers, where there can be metals within the water, surface waters, rivers, lakes, dams, streams, typical places where you could get suspended solids, also TOC, and more now a lot of organizations, due to environmental and sustainability issues, they're looking to recycle where possible secondary wastewater. So UF actually gives you the opportunity to be able to do that more now than previously. So that's quite an important area we should be looking at. If you look at the contaminants that are removed or reduced, UF is a physical membrane barrier. So it's very good at reducing turbidity, suspended solids, colloids, especially problematic colloids like silica, organics, TOC, and microbiological activity, to some extent bacteria, pathogens, and viruses. Metals, troublesome metals like iron, manganese, and arsenic can also be removed. And overall, UF as a technology, it can either be used with or without chemicals. It simply depends on the process. And Tim will talk a little bit more about this for you later. But these are the places where you would typically find UF in industry and the types of contaminants you would be looking to remove or reduce for your water treatment plant. So if you look at some of the benefits of UF, it's a continuous, reliable, and a steady state operation for the production of treated water. It actually produces a very, very consistent quality of water during its operation, because actually it's a physical barrier. So unlike conventional clarification or filtration where you can get hiccups in the operation, UF does give you a very consistent both flow rate and quality of water. It has a very high efficiency. Typically, most recoveries are in excess of 90%. This does obviously depend on the feed water and the contaminants that you're looking to remove, but typically it's very, very high compared to conventional treatments. And it has actually it has a very small footprint, which is great where you want to do upgrades or retrofits, or at existing sites where you've got some issues and some contaminants you want to remove, and space is obviously of an optimum that you sometimes can't build something within an existing facility. And the other thing, because it's a membrane system, it's a pumped process, this enables you as well to ramp up by adjusting the flow rates and pressures of your pumps. So you can actually scale up and scale down the amount of water you want to produce, obviously within the limitations of the membranes. So typically the qualities you're looking at, treated water qualities, microbiological reduction up to 6 log, which is 99.9999%, I believe. Typically TOCs or suspended solids, less than 1.1 NTU. And if you've got metals in the feed water using some sort of coagulation flocculation, typically about 95% metal reduction. And one of the good things is from a SDI point of view, if you're feeding a downstream reverse osmosis or even a demin plant, the SDI produced, it can be less than 3. So it's very good for pre-treating your current or your fixed permanent plant in the event that you've got any of these contaminants in your feed water and it's affecting the reliability and operation of your plant. So all of these points really would add up and give you a much more reliable operation of your permanent plant. So what I'd like to do now is to step you through a 3D walkthrough of one of our trailers. I think what we're trying to do here is just to purely demonstrate to you the compactness and the uniqueness of what this mobile asset looks like, and the equipment scope, and basically how it's configured. So if you just give me a second, I'll pop up the video and we can take a look through. So to start the video, as you can see, it's very simple. It's just a an external trailer, and then we sort of go through the unit and up through the steps and into the control room here. So you can see within here is a complete control panel. There's HMI. So everything for the operation of the plant is retained within this complete control system. Then over here, this is a unique feature of our system. This is the filtrate tank. So all the water produced by the unit is actually fed into this tank, and this is a 2,800 gallon tank. So from this tank, the water is normally sent with an external pumping system to your application. Typically, this tank is supplied as a separate piece of equipment, but with our assets, it's all combined into one. So this gives you a distinct advantage of having the asset actually within the equipment. Moving round, you can now start to see the infrastructure and the membranes. So this gives you one rack of membranes. Within our system, we've actually got 4 racks. So there's 16 UF modules in each of these racks. And the way the system operates, you can either run 1 rack at a time, 2, 3, or 4. And so that gives you quite a lot of versatility in terms of production output. If you're running the system below its maximum capacity, it also gives you a lot of versatility in terms of being able to switch equipment on, off, ramp it up, ramp it down according to your cleaning and CIP cycles and backwashes. So then just looking down the trailer, you can see here it's quite extensive until you come to this middle section of where the UF trailer is inside. So you can see everything's quite tightly packed in. Just over here, and this is the control and valving systems, let's say, for these 2 racks of membranes on this side, and it's actually replicated on the other side. So each system comes with its own online turbidity meter, so you've got complete visibility of what the treated water is at all times, so there's no surprises there. And you've got a specific flow valve which actually controls the flow in and out to each UF system. So everything's balanced, everything's monitored. So if you do have any problems or issues with the quality of the system, you can shut down different trains at different times, and you're not fully dependent only on one complete unit. And that's what it looks like at the back. So I'll go forward further, going back to the door again. And this is where we go a little bit outside. So it's a little bit slow, but we get there. And this is important. This is the rear of the trailer. So at the back of the vessel here, this is your CIP tank. So if you have to do any in situ chemical cleaning of the membranes due to fouling, so all of the control systems, all of the chemical systems are mounted here. And as you can see, you've got your various acid, alkaline, oxidants that you can put into these tanks, come up with the right sort of cocktail and formulation to clean in the event of any fouling of the membranes. And you can shut down, as I mentioned, individual trains one by one to make sure that you can clean independently. And at the front of the unit here, you've got all of your electrical power and connections. So again, it's very easy from an external point of view to connect up to this equipment, get it operational. So it's very much plug and play, put the power to it, connect the feed water and the drain, put your chemicals in as necessary, but everything else is within the trailer itself. So we thought it'd be useful there just to show you what the trailer looks like from inside and basically how the equipment is configured. So I'll go back to the presentation now. skip that. Okay. So hopefully that was interesting. If you ever want to see a piece of equipment as well, we can deploy one so you can see it. So what are the advantages of our system really, of the UFs? So the key advantages are that many of you might have experienced seasonal variations in feed water contaminants, especially if you're taking in water from rivers or any sort of surface waters. Contaminants can change due to heavy rain or dry seasons. So the good thing about the UF, it can be deployed very rapidly, very quickly, and as you see, it's all contained within the same unit, so it's very quick to start up and put into operation. So if you do have any of these environmental or weather-related disruption issues, we can mobilize a system very quickly to your site for short periods or longer periods of time, just to bridge that time period that you need to have your plant operational, whether otherwise you could be facing some sort of shutdown or damage or effect on your plant. It can be used, and it has been used, and I'll show you a case study later. You can install the system if you have to do any maintenance on your clarification system or on your filtration system. So you could actually bypass these assets and actually carry out hot maintenance, so there is no downtime to your plant. It can be used for trials. We don't normally do piloting for small baby units. We can actually do full-scale trials to validate something you might be looking at in terms of a pre-treatment or reuse water. So you can actually use these units to treat several hundred cubic meters per hour to really understand proof of concept. Short-term environmental conditions from a production perspective, you may be producing different products at different times of the year that may have different contaminants in them, which may stretch or or affect your discharge consent. So again, you could apply a UF here on a temporary basis to treat the wastewater to make sure you're fully compliant. And it can be used both for short term and for long term. So where CapEx is potentially an issue and you might be delaying an investment for 1 or 2 years, you could actually rent this for that time period, or potentially a longer time period. Why rent, why buy when potentially you could rent is a slogan there. So some of the unique features of our UF, as I mentioned before, it's very compact with very high flow rates. The 4 skids, they're actually capable of making up to 350 GPM each, subject to the feed water. So they can either be operated 1, 2, 3, or 4. So you can actually take 350, 700, 1050, or up to 1400 GPM from the unit itself. So it's very, very flexible. And when you do the CIP and backwash, because it's a very modular system, you only need to take off 1 rack at a time. So you don't experience, say, all or nothing or 50%. You'd only expect something like a 25% downturn in flow, while 1 unit CIPs or backwash is back online. So you are getting continuous production from the unit. And it's a very simple, as I've mentioned, standalone plug and play solution. So everything pretty much comes on the trailer, which optimizes things like logistics and freight costs. So when you look at the process train, it's got the highest and the latest, highest efficiency membrane technology we believe on the market. Comes complete with pre-screening. All UFs have to have pre-screens and taking out the lumps and the bumps from the feed water. The backwash tank and pump that we saw inside, and the membrane CIP system. And it's got a complete air scour system, because you don't always want to use chemicals to clean the membranes if you can just do it with an air scour that's more environmentally friendly. The membranes, it has an automatic integrity testing, so you want to test for leaks as well as measuring with the turbidity on the outlet, complete with chemical day tanks, and you could have an option of remote telemetry support, which would give you the typical main parameters you'd be interested in, like flow, etc., and common alarms, which is very important, and the waste neutralization to make sure that any of the chemicals you're using on board the system, they're fully neutralized before you discharge to your wastewater. So our approach is quite unique. We do work with our customers how they want us to work with them. So we can offer you very minimal operational activity with our clients, should they wish, or they can be involved more or less. It depends how they want to manage the deployment of this. We have 24/7 hour support to make sure all our assets are functioning very correctly, giving you the right quality and quantity of treated water. Our preference is always to use minimal or no chemicals with the operation of the system, but sometimes you have to use some. We adhere to all of the health and safety requirements, which obviously are critical with these pressurized systems and systems that are using chemicals from time to time. And we're there for as long as you need us. It's very much a pay-as-you-go service. It's very open-ended. So if we come on site, if you have a need for a week or two and you want us to stay longer, then we're able to extend that and work with you. So you can always be sure that you've got someone who's providing you with treated water. And it's a complete service, logistics, spare parts, support, reactive, proactive maintenance, engineer support. As you can imagine, we're there each day to help you through the operation of this equipment. There are some options available: additional pumping station, hoses and connections, and tanks and other accessories if you want them. And if you need them, we'd work with you to make sure we provide them all for you as well.
Great, thanks, Mark. That leads us to our second poll question here that we will be launching here on your screen shortly. Do you have any upcoming scheduled maintenance planned for your process water systems? And while we've got some people answering that, I do want to just remind you, and I can see that we've got quite a few questions coming in, but just wanted to remind everybody as well that to please feel free to ask any questions through the questions panel, and we'll try to get through as many of those questions at the end of this as time allows. Okay, looks like we've got the majority of people voting here, so I'm going to go ahead and close this poll here and share the results. So it looks like about a few here that have some scheduled maintenance coming up that they're aware of, but the majority, about half of it, currently no. So with that, we will rejoin the presentation here.
Okay, thank you, Jill. What I'd like to do now, we're moving on to the next section, which looks at the technology. So it's my pleasure to pass over to Tim, and over to you, Tim.
Thank you, Mark. As Mark went over, this is a very unique and a very versatile unit that we feel like offers some great design advantages. And when we put as much thought as we did in offering a lot of the things that you see in this unit, the one thing we didn't want to not pay attention to was what we picked. And we had a lot of options for filtration. We wanted something that wasn't a depth filtration. We wanted something that was lower pressure. So it was safer and required less operator involvement and less safety oversight. So we went with UF because it meets those needs, but it also, as Mark said, removes a lot of things. The 6-log reduction in bacteria, the ability to remove colloids, silt, dirt, things like fats and proteins if you're in an industry that may put those out, sugars, amino acids, or even be able to use chemistry to remove things such as metals and other processes. So we chose the UF membrane, and then we said which UF membrane, because there are a lot of ways to look at it. And so we worked really hard to pick the right membrane. Let's move forward, Mark. So we picked a membrane made out of that used fibers made out of PVDF. We did it because it has really good surface quality. It also is very temperature tolerant. It has a high chemical tolerance. So if there is a need to use chemistry ahead of it, the chemistry can affect the membrane. It will also allow the membrane, if we need to chemically clean it, to be able to handle that. But it doesn't need it. The membrane with its 0.03 micron pore size really does a good job in removing things with minimal or no chemical use. It has a very long life. One of the graphs you see shows the PVDF membrane compared to some of the other membrane materials, and it can take the pressure. The membrane lasts longer, the fibers don't break as much. So the good thing about that is that it keeps filtering the way we want it to on sites without having to put a tremendous amount of involvement in to repair broken membranes. We can use variable flux rates on this membrane from 24 to 82 GFD, so it allows us to get very high flows when needed, or take the membrane down when we need to meet whatever the individual plant's requirements are. If we go to the next slide, you'll see a little more on the design we picked. We decided to go from outside in, which means the filtrate water comes from the outside of the membrane, goes through the membrane surface into the inside. So clean water's on the inside of the membrane, dirty water's on the outside of the membrane. So what that does is it significantly allows us to tolerate a much wider range of incoming water from a turbidity perspective. It allows us to get the most efficient use of that water, and it also uses a dead end design. So when it filters, 100% of the liquid that comes in actually leaves as filtered water for you to use on your plant. Like I said, the PVDF chemistry allows for a very high chlorine tolerance, up to 2,000 when you're cleaning it, up to 200 if you're running normally. So if you have a stream that you need to be aggressive for bacterial control, it does that very well. It's a very high permeable fiber, and it uses a lot less energy. And we all know that parasitic demand is something we try to avoid. The last thing on the outside in design, if we go forward, Mark, it also allows us to get more use out of the membrane. If you think about, if we went from the inside in, if you look at the fiber itself, if we're putting contaminants inside, we're using much less of the surface area as compared to the outside. So what we do is we double the filtration surface area so we can hold more contaminants in between backwash. We also don't trap them in a smaller space. So when we go into backwash, it's easier to remove them. When you add to the fact that with a dead end, outside in design, we can add low pressure air to the backwash. When we go to remove these contaminants, we now get that scrubbing effect that the air has, the small bubble and the lower the transmembrane pressures stay, allowing us to backwash less frequency and deliver a higher quality of water. The dead end design also makes it easy for the system to monitor if there is a broken fiber, and allows us to repair it much more easily. So it's just a little bit of why we did it. We feel like that the membrane itself is the top end technology available for use in UF, and we think it offers this unit with the other design features to be something that is easy for people to operate without having to put a tremendous amount of involvement. The next slide is just a kind of a little bit about why didn't we pick something else, and compares it to microfiltration. A lot of people like that. It's a great technology, but it is a more of a depth filtration technology. The size of the pores and the way the membranes are designed allows debris to penetrate into the membrane pores like a depth filter, which means it can't be cleaned as well. So, so you have to be more aggressive either with chemistry or other things to clean the membrane. You backwash it a lot more frequently. So because of that, we decided that we wanted to go away from that technology, especially when you add to it, it does not do as good a job removing things like microorganisms that are a big issue if you're running downstream membrane processes like reverse osmosis or EDI, things like that. And then the last slide that we have kind of in the technology is a video that kind of shows how this technology works. So as you can see here, the water that needs to be filtered comes in through the bottom of the membrane and flows along the outside of the fibers. And the water then is pressed through the fiber with the debris staying on the outside, the clean water going to the interior of the fiber as it moves up the membrane. When it gets to the top, the debris is left behind and clean filtrate exits the membrane to be used. Then when the unit detects that there is a need either on time or on pressure, there is a backwash needed, we reverse that flow and we bring water through the inside of the fibers, press it to the outside to release this debris, the filtered water, and it leaves and takes that out. Then we inject the air into the membrane to scour the membranes with low pressure air that will further help to remove any debris that has not been dislodged by the inside out backwash. That water is, that air then helps remove it. The debris is then loosened and we then do a rinse with treated water and return the membrane back to service the way it was before we had to do the cleaning. It kind of backs up what we said. It's a very good process.
Good, thank you very much, Tim. Excellent. That sort of covers the technical side of the presentation. Tim's obviously still on the call if you've got some further technical questions later. What we're going to do now is we're going to move on and talk about just a few case studies for you. The case studies are presented quite simply just to give you a feel of what we can do. But of course, again, we're very much welcome to talk at any time with you about any potential applications you're looking for. But before we get then, Jill.
Great, thanks, Mark. The last poll question that we've got that I'll launch here shortly here, should pop up on your screen, is do you experience issues with fluctuating feed water quality to your raw water plant? So, and as we are collecting the responses right now, I do want to mention, and I forgot to mention at the beginning of our presentation, but we are recording this presentation, so that will be made available to you within about 24 hours or so as well. So if that is something of interest, be on the lookout in your email for the recording of this presentation. Okay, so it looks like we've got the majority of our results in, so I'm going to go ahead and close this poll and share the results out. So it looks like pretty much the majority, either constantly or occasionally, are having issues with their feed water quality or different seasonality fluctuations. So with that, I'm going to turn it back to Mark to talk a little bit about how we can solve some of those issues.
So here are some of our North American case studies. I'll just talk through three that we've selected, which are specifically relevant for this presentation. So this was an oil refinery in Canada. They had an emergency situation where they were planning to shut down their clarifier. It was coming up for maintenance. It was just limping along. And then suddenly there was a failure with it. So from going for something that was going to be a planned maintenance, this really went into quite an urgent sort of emergency. The source of water the customers treating was river water, and this was actually feeding their demin system. So for those of you working metric, we actually supplied a system up to 545 cubic meters per hour or up to 2,400 GPM. The cartoon in the bottom basically shows the assets that we supplied, what was our solution. So we actually had two of our ultrafiltration trailers working in parallel, feeding two storage tanks and two pump skids. So we could actually receive the water from the customer, a pressurized feed, treat the water, put it into storage tank, and then pump it forward to their demin system. And the benefits for the customer were quite simple, really. The suspended solids, the removal rate was less than 0.1 milligram per litre. That was critical to them for their operation. And this system ensured consistent water quality to that customer for about 6 to 8 weeks to make sure there was no fouling of their demin plant and no subsequent damage to their downstream boiler, which was quite important. And the key thing for the refinery was they didn't experience any interruption within their production of what they do is refine hydrocarbons. So it was a very key solution for them to help them get through this emergency condition until they could get their clarifier back into operation. The second case study is in Canada. This is where we're working with a client for a multi-year solution. So typically this pulp and paper plant in Canada was experiencing seasonal fluctuations in the quality of their river water. And in this case, it was not so much solids, it was mainly organics, as you can imagine, natural organics in the water. And so they were really looking for a solution to provide them with some pre-treatment system for their demin plant, because the organics were both fouling the resins, they were going through to the boiler and disrupting the boiler chemistry. And one of the key criteria for this customer was an existing site, a very mature site. So you can imagine they didn't have a lot of space available. So they were really pleased to see that we could offer them a high capacity unit, high flow rate that would actually meet their requirements. So the flow rate here was 275 cubic meters per hour, 1200 GPM. And the cartoon at the bottom shows there that you've got one of our units feeding a storage tank and then pump it onto their water treatment plant. So the benefits for the customer was here: consistent water quality, removal of TSS iron organics. It prevented any further fouling or inconsistent operation of the demin plant of the boiler, and of course their production wasn't interrupted. And another key benefit for this client as well, they didn't have to go for CapEx before they could get this system. It was really a question of just putting in place an agreement with us, which is we're very quick to do that, and they could have the asset within a short space of time. So that really helped them out for this application. A chemical plant within the United States. Again, going back to the typical application for it is customers got problems with clarifier, an older type of system, so inconsistent water quality coming from that clarifier based on the fluctuations in the feed water. And they were feeding, after the clarifier and filtration, they were feeding into an RO. So they were having high costs of maintaining that RO membranes, cleaning the membranes, and also the reliability of their water treatment plant to help them meet their production needs was obviously at risk. So as the last solution, 1200 GPM, we provided one UF, a storage tank, and a pumping system. And this was under a more of a pre-planned agreement with the customer. You know, that they only experience this problem intermittently, so they actually planned ahead, typically when the seasons when they have this bad quality water. So we was able to prepare everything, make sure we had everything organized for the client, and then be on site and then leave once it's finished. So again, as the last one, TSS important organics, pre-treated an RO, so the SDI was less than 3, which is really good, and supplying a very low TSS water as well for their cooling tower, because this system was both supplying the cooling tower as well as the reverse osmosis. So hopefully that puts a bit of reality into some of the theory and stimulates some thoughts and ideas, just in case there's anyone here that's having problems similar to those. Of course, everyone's site is unique, so that's where we work and with our customers. So just to move on to the next section, really now we want to talk about what we will deliver and what we would take care of working with you. So it's a very simple slide. It's, what do we deliver as a service provider, and how do we work with you to deliver a reliable solution? So typically we would look at and manage all of the process support and supply our expertise from a process and equipment perspective. We would manage your full logistics, transportation. Colleagues like Tim on the call would look very carefully at the membrane, apply their expertise and knowledge to how they can not only apply the membrane, but also how we can operate it in a very optimized way for you. We manage all the proactive and reactive maintenance and spares with our technicians, any chemicals, and obviously we supply the technicians to both start up, commission, help you train your operators if they're going to do the day-to-day readings, etc. So we really do as much here for you as you want us to, and we're very flexible in how we sort of mix and match that with your site resources. So really what we ask you to manage is the feed water, things like the infrastructure, where we would put the equipment, the security around the assets when they're on site, define for us the treated water requirements that you're looking for to help us to make sure our equipment can deliver that to you reliably, the power, the wastewater, and any site characteristics, specifically where it's related to health and safety, so various inductions and things, and just behavior on site to make sure we're complying with, I'm sure, the high standards that you've got on your relevant site. So the final sort of section I've got before a brief summary is when is it an advantage to rent versus buy? That's always a choice. We're faced more and more now in our private lives, but it's now certainly a big thing in industry. Should you buy or should you rent? So we wanted to make sure that you've always got a choice there to buy or to rent, because if you'd like to rent, then you can obviously work with us at Mobile Water Services. But if you're looking to probably procure something more on a permanent basis, our other Veolia water technology colleagues, they could support you with that application as well. So when you look at some of the bullet points, why you would rent against maybe buying, certainly for short-term or intermittent needs, there's probably a big advantage to rent, because the time periods we can be on site for you can vary from year to year. So really an investment is probably not the way to go, because you could have time periods where the equipment's just redundant. So you really pay as you go, you call us when you need us. So short-term and intermittent needs may be the way to go. If you've got some challenging waters you want to treat, partner with an organization like Veolia, who can deliver you the expertise, a reliable system that's going to operate uninterrupted with all the support services I've mentioned before. And that could be a good way to go, because it actually gives you that sort of peace of mind that you're working with a reliable company, that you're always going to have the quality and quantity of treated water available to meet your production needs. Because at the end of the day, that's the most important thing, that you've got treated water and you maintain 100% of your production in your facility. Pay as you go. One of the good things about renting versus capital expenditure, it comes directly out the operational budget for the facility. So that allows you to do a couple of things. You can move very quickly, you can get the equipment, you can get the solution very, very quickly in case you've got a bit more of a complicated CapEx procedure within your organization. So you can actually benefit, and your organization can benefit from having this technology very, very quickly. And then multi-year, if you really don't want to go down the capital procurement, you really want a hands-off, you can work with us for a more permanent solution. and we're able to rent the equipment for you, typically up to 7 years. So 1 year, 2 year, 5 years. We extend those agreements as well based on our customer needs. So that gives you the flexibility. And the other key thing we see now, especially post-COVID, is supply chain volatility. You know, you may be looking to install some equipment in 6 months, in a year, or some sort of similar time period to that, but you find today everything is being pushed back. Everything, you know, deliveries are being extended. So if you need the technology, we can work with you in the short term to, you know, help you meet your needs, sometimes without waiting so long for the equipment. So that's another important why rent when versus buy. And you know, renting a UF is a perfect solution for a temporary solution, and especially what we see today is, you know, we live in an ever-changing environment. If you went back 40, 50 years, I think there was a lot more stability. So renting does give you that flexibility and versatility that you might want to choose against a permanent solution. So just in summary, you know, a mobile UF solution, it really gives you an excellent pre-treatment for your water treatment plant. The key thing, it adds reliability. One of the most important things about a water treatment plant is it can produce 24/7 to the quality and quantity you need. So that's very, very, very critical. It doesn't use so many chemicals. Depending on the water, you may use some, but it's a physical barrier, as we've mentioned before, and so you get a consistent treated water quality out of it. And because of the reduction in chemicals that you may use, it's more of an environmental solution. It's a very compact unit, as what the videos have shown earlier. So very, very high capacity in a very small footprint, which is essential, especially if you're an existing mature facility where space is a premium. And its flexibility to actually scale up, ramp up the production, reduce the production based upon your needs, which might be quite cyclical. All of the pumps have inverters on them, so it's simply a question of regulating the flow rate, and the membranes respond quite efficiently. We consider that the membrane, as Tim explained a little bit earlier, is probably one of the best membranes on the market that we've chosen to select. This gives us the additional capacity, the performance that we're looking for, and it optimizes the water production rate. So we feel very confident with that. As I've talked through before, the system's very simple to install, very much plug and play, electrical supply, feed water, treated water, drains. It does take a little bit of time for the engineer to commission it and to get stable operation, but fundamentally it's a very, very responsive and quick system that we can mobilize to your site in the event you need it, and especially if you're experiencing some sort of emergency condition that may disrupt your production. And we at Veolia, being an environmental organization, we see the UF as a key part of our innovation in our water treatment portfolio, because it gives us more opportunities to recycle, reuse water that otherwise would have been considered for discharge, and could also give our customers the benefits of not having to import other resources to substitute this water, that you can get more of a closed loop by recycling some of your wastewater for processed water applications again. So that's the end of my presentation and Tim's presentation. We'd both like to thank you very much. I'm going to move on to the next slide, and I think Jill will take it on from there.
Great. Thank you very much to both Mark and Tim. We do have a few minutes left here in our time, so I've got quite a few questions, so we'll try to get through as many of these that we can. And for those that we don't get a chance to answer, we will follow up directly with you afterwards. So with that, that'll kick off our Q&A session. First question that I've got here is, typically, how long does it take for one CIP cycle?
Tim, do you want to take that?
Are you it's a CIP? A CIP, it depends on, well, what we're trying to remove, but typically a true clean in place, if you're not talking about a backwash or a chemically enhanced backwash, will usually take around 2 hours.
Great, thank you, Tim. Next question that we've got here is, what's the maximum turbidity and or TSS that the UF system can handle?
Well, for short periods of time, turbidity limitations we usually look at are 300 NTUs. We can that is kind of the max. We don't like to run it there continually. And then TSS would be 100 milligrams per liter maximum for shorter periods of time. Usually we'd like to keep that a little lower for continuous operations. Yeah.
Okay, and then also there's a question here asking if you could comment on how the system would handle algae.
It will remove algae. A lot of times, you know, algae is a difficult thing to remove if it comes in these large mats. Sometimes the biggest problem with that is getting it through the pre-filtration. But if the algae is broken up and chlorinated, the nice thing about the membrane we use being able to tolerate some pretty high chlorine numbers is that we can use an oxidant to burn the algae up, and then the particulate matter gets filtered out very well. I mean, the filtration is pretty absolute with a 0.03 nominal filter size. Mm-hmm.
Great, thank you, Tim. I've got a couple different questions here regarding the backwash. So the first one is, how much backwash volume or waste is produced, and how do you recommend managing it?
Well, the backwash flow rate that we use is at the lowest level of 24. We do 24 GFD. It depends on how often we do it. I mean, we don't backwash we usually set the backwash frequency based on what we see at site. The nice thing about the trailer design we have is if we're using any chemically enhanced backwash, we can neutralize that before it goes out. And so we're giving you a water that would then be just discharged, usually into a drain that feeds your wastewater facility, or if you go direct to the city, the POTW or whatever, that we do that. Usually the backwash, a lot of the backwash with the air scour, we don't even need to use chemistry. Therefore, it's really nothing but water and the sediment we've removed. And in a lot of places, we're able to really discharge that back to the tributary if we're taking out of a river, because we've not put chemistry in it and altered it. We're able to send it right back because we're basically returning clean water that was filtered with the same contaminants we removed.
Great, thanks, Tim. The second question regarding backwash as well is, how long does it take to do the UF backwash, and when to replace the UF membrane while managing the continuous operation?
I'll just talk briefly about the membrane replacement, if I may. You know, the membranes are pretty much within our scope of supply as a service provider. So typically, you know, unless there's some serious disruption for the feed water that we're operating beyond the physical capability of the UF. These membranes are very robust and very durable, as Tim has mentioned. So they do last for years, I should say. And the good thing again about our system, and it comes down to the modularity of the system, you know, if you have to replace some membranes, you don't have to replace them all. You don't have to shut down a complete plant. You can just shut down one of the skids to do that. And quite honestly, that they're quite straightforward to remove. They've just got clamps at the top and the bottom. You can slot them in and out. So you could be replacing a complete module really within sort of a day or so, while you're still making water with the rest of the other system. If you're running the system at maximum flow rate, then the other benefit we can bring, and membranes need to be replaced, we can bring in a secondary unit to make sure that there's no disruption in the flow, and then replace the units either on site or off site and rotate the units according to what our customers want.
Great, thanks, Mark. I think we've got time for one more question here. Does UF pretreatment assist with preventing biofouling in RO units?
The answer is most definitely.
Great. Well, with that, that will conclude our
I mean, I can give you a
webinar
very
today.
long answer on biologics, but it does assist. If you have very high bacterial counts in the water, two things that we can do. We can either use chlorine and sterilize and remove what aren't killed, but with a 6-log reduction in bacteria and viruses, that is, you know, as Mark said, 99 to the third decimal place removal of those. So if you consider that you take that much out, if you have a tendency for biofouling, that's going to help tremendously.
Great. Thanks for that, Tim. And with that, that will conclude our webinar today. I do want to thank both Tim and Mark for presenting with us today, as well as you guys for joining us. As I mentioned, this webinar has been recorded, so a recording will be sent out to you within the next 24 hours or so. And I do apologize for those that we did not get to your questions, so we will follow up directly with you if we did not get a chance to answer your question. And with that, that'll conclude our webinar. If you do take the survey, you will be entered into a drawing for a chance to win the $25 Amazon gift card. So please fill out that survey as we conclude our webinar today. And if you are the lucky recipient, we will follow up directly with you. With that, thank you for joining.